was 5 years old, I learned about the coolest magic trick. And I was so compelled by it, I had to try it out on my own. So I found an old Hills Brothers coffee tin that was emptied out. I put some dirt in there, sprinkled these things called seeds, watered them, and I waited a bit. And before I knew it, I had sprouts coming up. And I was so excited, I had to run into the house and show my parents. And I bet they were thrilled when I told them that I grew dandelions. This curiosity and this interest with plants went throughout my childhood, and it conflicted with a lot of other natural things I loved in nature that I wanted to pursue as a career. But in 5th grade, I learned about native plants in particular, and what I had the connection there was there's some detention ponds near my neighborhood that had these things like swamp milkweed and switchgrass in it. And I'm like, oh, I could probably grow these and put them in my parents' yard, learn about them. And then I started volunteering with Citizens for Conservation, learning more about native plants, and some of the folks are like, yeah, we're having a hard time restoring some of these. In my mind, I'm like, well, I grew that mayapple. Maybe we can try growing some for you guys. And so, believe it or not, they gave me a seed to grow. And so college decisions came by, and I had a conflicting decision. Do I pursue my love of birds by going into ornithology, or do I pursue horticulture with my love of plants? And of course, I'm like, well, girls like flowers. If I learn how to grow flowers, maybe it makes me more eligible when I get into college. All right, I'll do that. But all joking aside, this whole principle of conservation through cultivation really drove me to pursue growing native plants. And that's what I did with my horticulture career, and that's what I do to this day as a plant propagator and as a seed manager, trying to figure out how to restore these rare plants in our natural areas and also utilizing them in our landscapes. But I want to talk about seeds because seeds are pretty incredible if you think about it. These objects, they've helped plants spread across the world into some of the most challenging environments. They've helped plants survive mass extinctions that wiped out organisms in the past. And without seeds, we as a species and civilizations would not exist. And all seeds are very unique, just like us. Take this bloodroot seed, for example. It has a growth on it called an elaiosome that is used to attract ants, and ants are the dispersal agent for this woodland wildflower. A lot of our native plants, they have to overcome this challenge called winter, if you think about eastern and central North America. And all seeds, they have to go through a process before they germinate called stratification, which is essentially a combination of temperature, moisture, and time. So all seeds, they need what's called warm moist stratification. If you think about you're sowing a tomato seed, you plop it on some warm potting mix, give it some moisture, keep it at 70 degrees Fahrenheit, and in a couple weeks you have a sprouting tomato. A lot of our native plants, they drop their seeds before the chill of winter comes, and if they were to sprout before then, they would perish. So they have to go through another process called cold moist stratification, aka winter. And so depending on the species, they need a certain length of time for this. And what I try to do with our local plants, because again, I want to make sure that they're surviving in our restorations well, I try to mimic the length of time of the winter period that they've evolved in. So if you think about our Chicagoland winters, for example, it's about 3 to 4 months. So I try to do a 90 to 100 days or 120 days cold moist stratification for these seeds. And I get really good results with that. Some species you don't need that long, maybe even 30 days cold moist stratification. But again, how is that going to help them progress long term for their surviving populations in the wild? Am I going to be breeding that long term? It's probably not best for the plants. And the easiest way to do this, you can sow seeds on a tray, leave it outside in a protected location for the winter. Or you have in a controlled cold environment like a refrigerator and damp sand, damp vermiculite, and you'll get the similar results. And of course, the plants are going to tell you when they want to grow if you leave them in the fridge too long. I had these American hazelnuts in the fridge for about 180 days, and they started sprouting in there. And of course, their roots are flaring out. They want to get in the soil really bad, so I had to plant them pretty quick. So now prep work is key for some plants, especially ones that produce fleshy fruits. Let's take this doll's eye, for example, who's always watching you in the woods, so don't cause any trouble. A lot of our berries, they have chemicals around the seeds that inhibit germination. In the wild, these berries would get ingested by an animal, and those digestive juices would break down these chemical inhibitors and ultimately spread the seed to a new area and help it grow better. Now, in my case, a lot of these fruits are toxic, so I can't eat them, and I don't want to be sifting in my stool looking for the seeds. So the easiest way to accomplish this is to crush up the berries and put them in a cup of water for about a week or two and let them ferment. But when you thoroughly rinse them after this, you can get up to 100% germination rate, and this has really helped restore some of these plants in the wild. There are other seeds that they just need a little bit more time, and patience is your greatest ally whenever growing plants. These seeds are what I call double dormant, so they take 2 years to germinate, and there's a couple examples of these. One here that I have is called Michigan lily. It's one of my favorite native wildflowers. In its first summer that it germinates, it produces a tiny little bulblet with maybe a root or two, and then it'll go into the fall and survive the winter as that bulblet. And then the following spring, it'll send up one leaf, if you're lucky, maybe 2 or 3. But in the greenhouse environment, you can get up to several leaves during that first or that second growing season. And one of the rules that I've learned when growing plants in the greenhouse is that you can double their growth rate. And some of these Michigan lilies that are in year 5, and I've still not seen flowers, which means in the wild it could be at least 8 to 10 years before you see flowers on some of these long-lived plants. Similar on the left-hand side is ginseng, and the right-hand side is Nannyberry viburnum, both of these natives. These are also double dormant seeds. And what's going on here is their embryo inside the seed is not fully mature, so they have to go through another warm period in order for that embryo to mature before they germinate their second growing season. And of course, plants, like all organisms, they don't like to follow the rules in the biology textbooks that you read. So sometimes they'll go beyond the 2-year process. This one was a 3-year germinator for me. This is called blue cohosh. This is a native woodland wildflower. I sowed the seeds in fall of 2020, and then 2021 I got a little root coming out, that little yellow in the center on the left-hand side. And it was like that for another year. And then 2023, they actually sent out a long rhizomatous root with a bud at the end, and stayed like that. 2024 is when they send up their first leaf. And then some plants, they might take longer. This is great burrweed. This is a keystone species in our marshes. They take at least 2 years to germinate, and that second year, I got nothing. The third year, I got 6 plants. That's a win for me. The fourth year, I got 100 plants. And I'm like, okay, can they do this? Maybe 5 years? Can they get more? I got 250 plants the 5th year. You have to be, again, patient and a tad bit insanity added to it. But again, this is important information for me to know how to restore these plant populations, because if I don't see results quick, I just need more time. Some plants, they sow way better on their own rather than you going out and sowing the seeds. And so I have to introduce them in the specific spot in order to do that. So I grew these violet wood sorrels in the greenhouse. They germinate beautifully and they grow really quick. And then I wait till they go dormant, which is the second photo. They go into this like corm or bulb during the midsummer months. And then I went out there in the blazing heat with a pole, and I made holes, dropped the little corms in there, and they're still surviving today. And the idea is that they will be shooting their seeds throughout that area in order to restore themselves. Then there's the whole thing called scarification, along with stratification. And scarification is abrading a tough seed coat so that water can imbibe into the seed and get that moisture to the embryo. This is a challenge with a lot of our legumes, so members of the pea and bean family. And one easy way to do this is to take sandpaper and you abrade the seeds gently, and then you soak them for about 24 hours in water and let them go through their stratification process. There's another technique called hot water treatment, which you pour near boiling water on top of the seeds in order to crack the seed coat, let them soak overnight, and then they stratify them. So I want to test these two approaches on one species of plant called white wild indigo. And so I got seed from the same population, did the same stratification length, but I used hot water and sandpaper. And the tray on the left-hand side was the hot water treatment, and they went crazy, versus the one on the right-hand side where I just used sandpaper. Why is this important? A lot of our native prairie plants have evolved with fire, and so when we do prescribed burns, it actually helps germinate the seeds of a lot of our native plants. This is also the same for this one called New Jersey tea. The only way that you can germinate these seeds is if you pour water 200 degrees Fahrenheit on it, because it needs the heat from that to crack the seeds. And when you do get that heat, they go bonkers. Some plants, they need, especially in our wetlands, they like a little bit shallow water to germinate rather than just having moist potting mix. So I have the two examples of common arrowhead on the left and large leaf pondweed on the right. With a little bit of light and about a ½ inch and a ¼ inch of water, you'll get really good germination results for some of our wetland plants. And one of my favorite groups are the hemiparasites. So these are plants that they can photosynthesize on their own, take up water and nutrients on their own, but they like to steal nutrients from their neighbors and also reduce competition from neighboring plants. And a lot of times these have been ones that have deemed to be difficult to germinate. So of course I wanted to try this out because I want to get this right. I want to crack this code on some of these plants. And so the one example here is wood betony, which kind of looks like an arugula leaf. One of my favorite native wildflowers. And so I planted these with a host of the host plant is called a sedge, which if you're not familiar, it's a grass-like plant. And I also did ones without a host. And the best results I had as far as growth and vigor were the wood betonies with a host. The ones without a host got really chlorotic and sad, and they didn't really do well in their growing trays. Now, of course, I've grown 300 species of native plants roughly. And there's only a handful that I still have not figured out, and it's driving me nuts. I have not cracked the code. Here's one of them. This is called horse gentian. It's a weird member of the honeysuckle family. It produces these fruits that look like cherry tomatoes, but inside of them are 3 hard seeds. So its genus name is Triosteum, which means 3 bones. They have a very thick seed coat. So I've tried scarification, nothing. I've tried hot water treatment, nothing. I've tried natural processes, nothing. I have one more trick up my sleeve. Sulfuric acid. This stuff can burn my flesh, so I had to be very careful with this. And I did 2 treatments. One was for 2 hours soaking in sulfuric acid, and the other was 3 hours soaking in sulfuric acid. And I based this time frame on a similar seed with a similar seed coat density called a hawthorn. And they use this technique to germinate hawthorn trees. So I tried it on the horse gentian. So the seed on the left-hand side is untreated versus the ones on the right. So of course, when you're germinating plants and growing plants, documentation is key, so make sure you're taking a lot of photos. And I even checked the insides of the seeds to make sure I didn't dissolve the endosperm or the embryo inside. And you can see between the left-hand side, which is untreated, and the right-hand side, which is treated, there's barely any dissolving of the seed coat, even after 3 hours in pure sulfuric acid. So I ponder myself, how does this plant reproduce? Does chipmunks eat it? Did passenger pigeon eat it, which is now extinct? What's going on here? And I still have yet to grow these. If you figure this out, you let me know. I will come over and learn from you. Of course, there are some plants that they don't do well in the greenhouse, and they just need to be on their own schedule, because again, plants, they're on their own time, their own pace. They're not in our microwave society, a lot of our schedules. And so I just have to trust the natural process. The sadly named bastard toadflax in this photo, I went out with its seeds with a tent stake down the trail, dropping seeds in so I can mark where I've been. And I got a couple of these that germinate out of a couple hundred. And so the one on the left-hand side is spring of 2020, which is I saw the first germination. And then the one on the right-hand side is this 2024. This is important because nurseries have not figured out how to grow this plant. So to me, this is a win. And when you gain more confidence, you start to play around with different plants that are rarer. And I'm like, what else could I figure out? And so we have the prairie lily on the left-hand side, one of my favorites. Fairly easy to grow, just hard to restore. Then your name starts to get out. And the Chicago Botanic Garden figures out, hey, you're growing some stuff that we couldn't figure out. We have this plant called low bindweed. It's a state-threatened species, and we haven't figured out the seed yet. Can we give it to you? Sure, I'm up for a challenge. So I did grow a few of these low bindweeds, which are in the center's photo. And then I had a plant that I only knew a handful of people across the country that grew it, so I want to try it out. It's called hoary puccoon. And when I got a couple hundred plants germinated, the forest preserve freaked out. They're like, you got that to germinate? What? We've been trying to figure out how to grow that forever. And I say these things because, again, I'm not trying to produce numbers of plants. I'm not trying to make a ton like money on these plants. It's for conservation through cultivation. What if we were to make seed beds of these rare plants that have the local genetics we're looking for to restore and collect seed off of them? And these germination tests I do help me better understand how to restore them. Are we sowing them at the right time of the year or not? How do we change that? And just trying to combine different genetics from across these remnant populations of these plants that are disappearing rapidly through habitat destruction, climate change, and invasive species, just to name a few. What if we can create these seed beds not just in nurseries, but also your backyards, some of our community landscapes? This can go a long way for not just preserving these plants, but this local biodiversity. And my main thing tonight is that you don't have to be an expert horticulturist or an expert botanist to know how to grow plants. You just have to have the patience, the curiosity, the capacity to slow down, really learn about the plants, and of course, throw in a little insanity in there every now and then.